video here for lesson number 7 on geometric series. We've already done some work with series in lesson 6 where we used the summation notation to find the sum of a series or the sum of a sequence, which we call a series. The opening exercise is something that we can do. All right, so either use your calculator or plug in numbers and see if you come up with the sum of this sequence. All right, so hopefully you tried it. When I plugged it into my calculator, I got 635. If you're somebody that has an older calculator, doesn't have that feature, you could just type in 5 times 2 to the 1 minus 1, plus 5 times 2 to the 2 minus 1, and keep going until you get 5 times 2 to the 7 minus 1. Add up all of those terms, and you should also get 635. So in a perfect world, in class, we go through and actually prove something in the next part of the lesson. I'm not going to do that in this video. I'm going to have you look that up if you're interested in it. So if you're interested in how this equation that we're going to use on the next page works, you can do that. Just Google geometric series formula, how to prove it, and it'll pop right up. It's not hard to do. But here is another form of this series formula. So one of the things that happens with a geometric series, because of their pattern, it lends very easily to coming up with an equation that we can use to find the sum of a sequence. So to find the sum of a geometric sequence, we can actually plug in the first term, the common ratio, the number of terms that we have that we want to find the sum of, and the common ratio, and find this series value or this sum of digits without actually having to find all of the digits. So this first opening exercise problem has a first term of 5. So the first term in the opening exercise was 5. The common ratio in the opening exercise was 2. And there were 7 terms. That's the number on top that tells you how many terms we're trying to add up. So if you plug this in to this new equation, I can say the first term minus the first term times the common ratio to the number of terms divided by 1 minus the common ratio. Now, if you type that into your calculator, I would use the fraction button, alpha y equals 5 minus 5 times 2 to the 7th power, all divided by 1 minus 2. You get the same answer, 635. Now, this is a really helpful thing for those of you that have the old calculator, because now if you see something's a geometric sequence and you're trying to find the sum or the series value, you can do it using this formula instead of using the addition method that you've been doing. Okay. The other thing that's nice about this formula is it gets to the answer without having to use that whole sigma notation thing. So let's find a couple sums here. So for this first one, you could totally just add up those 7 numbers, but I'm asking you to actually use this new formula. So there are 1, 2, 3, 4, 5, 6, 7 terms. So the sum of these 7 terms is going to be equal to the first term minus first time times the common ratio. Get from one term to next, we multiply by 2. There are 7 terms, 1 minus the ratio, and see what we get. So go ahead and plug that in. So alpha y equals 3 minus 3 times 2 to the 7th power, 1 minus 2, and we get a series value of 381. Now, not all of them are going to give you all the terms like this next one. So to find this sum, we have to figure out, well, how many terms are there in this series that would give us that last value? So I know that the first term is 1. I multiply by 3 each time. So my explicit formula is any term of this sequence is going to be 1 times 3 to the n minus 1. So we can just kind of plug in n values until we figure out which one gives us 2,187. So if I do 1 times 3 to the, we'll say 9 minus 1, that's way too big, to the 8 minus 1, 8 works. So there are 8 terms. This is the 8th term of the sequence. So I can say S sub 8 is equal to the first term minus the first term times the ratio to the 8th power, all divided by 1 minus 3. So go ahead, plug it in your calculator, see what you get. So I'll plug it in with you here. And we get 3,280. So that would be the sum of all 8 of those terms. Now, sometimes I'll ask you to find the sum, and they're giving it to you in this form. So we know that there are 10 terms. There's your n value. That's the first term. We know that because it's an explicit formula. And here's your common ratio. So we just plug it in. So I could say the sum of the 10 terms is equal to the first term minus the first term times the common ratio, all to the 10th power, and then 1 minus the common ratio. So go ahead, plug it in, see if you're getting the same answer as me. All right, the big thing here is make sure you are plugging it in correctly. And we should get 3.33 ... Change it to a fraction. It works. So we could say this is 1705 divided by 512. All right, so next one, we notice that the exponents are increasing by 1 every time. So even though this exponent's 11, this is actually the 12th term. Right? If you look, the second term it has an exponent of 1, third term has an exponent of 2. So I know the first term, I know that there are 12 terms. I know the common ratio because I see the multiplier is 1.005. And we can just plug that into our calculator. So go ahead, plug it in, see what you get. All right, so for this one, I got the sum of these 12 terms. The series is 493.42 ... Doesn't say what to round to, I know. It doesn't change to a fraction, so we'll just leave it as is. All right, let's take a look at another one. It says the sum of the geometric series with 4 terms is 60. They're telling you S sub 4. They're telling you the sum. Common ratios are, and it wants us to find the first term. So the first term is A sub 1. So I'm going to let A sub 1 just equal A, so we don't have to keep writing sub 1 every time. So I know that the formula is the sum is equal to the first term minus the first term times the common ratio to the number of terms, which was 4, all divided by 1 minus the common ratio. So if we do some algebra, we should be able to figure out what A is. So I could say 60 is equal to A minus, now if I do 1/2 to the 4th power, I get 0.0625. And then this is all going to be divided by 1/2. Multiply both sides by 1/2 to get rid of this. And I have 30 is equal to A minus 0.0625A. Those two terms are like terms. 1 minus 0.0625 is 0.9375. And then just do some algebra. And we get an A value of 32. That's my first term. All right, let's see if you can do the next one by yourself. It's the same idea. So pause the video, see if you get the same thing I get. All right, so welcome back to the video. I'm hoping you at least got this far by yourself, and then you notice something. You notice that the exponent is the variable, meaning for this question, you're going to have to use logarithms to solve it. So if you got this far, give yourself a pat on the back. That means you know what we're doing today. But to get to the next step, or to get to the answer here, you're going to have to know a little bit from the last chapter. So if I do some subtraction, then divide by -3. I don't know if you guys could hear my daughter getting absolutely nuts upstairs. I apologize for that. We get 4,096 is equal to 4 to the n. Then from here, we could take the natural log of both sides. I know you don't like seeing this in a problem, but it does keep coming back. The n comes to the front, so I have the natural log of 4,096 is equal to n times the natural log of 4. Divide both sides by the natural log of 4. And we should get our answer for the number of terms of this sequence. So if I do natural log of 4,096 divided by the natural log of 4, I did 95 for some reason, divided by natural log of 4, I get an n value of 6. So I can see that there are 6 terms in this sequence. So the nice thing about this new series formula is it can be used to find missing first terms, missing number of terms, or even the common ratio using algebra. Number 6 is kind of just busy work, so we're going to skip number 6 in today's lesson. If you really want to do it, you can. It's just busy work, so you could skip over it. All right, let's move on to the homework assignment. So at this point, you can pause the video, try your homework, see how you do. It's very similar to what we just did in class. And then we can go ahead here and check your work in a couple minutes. Okay, so pause the video and then come back. All right, so hopefully you pause the video. So it says find the sum of the first 8 terms. Notice we don't even care what the 8th term is. I just need to know how many terms I'm finding the sum of. So I'm finding the sum of 8 terms. I know the first term is 3. The common ratio to get from one term to the next is -4. And then if I type that into my calculator, so I'll do 3 minus 3 times -4 to the 8th power divided by 1 minus -4, I get -39,321. The next one is set up first. It tells us how many terms there are. That's the n value. It tells you what the first term is. And it tells you what the common ratio is. So I could say s sub 7, 2 minus 2 times 1/3 to the 7th power, all divided by 1 minus 1/3. Type it in, see what we get. And we get 2.998 something, and it even changes to a nice fraction for us. And we have our sum. The next one has 61 terms. This term is a sub 61. I know that because the second term has an exponent of 1, third term has an exponent of 2. So if I want to find the sum of these 61 terms, I'm going to say the first term, common ratio 1.03, and then 1 minus the common ratio. So go ahead and type it in. The formula is actually not that bad if you haven't noticed yet. It's the same thing every single time. We just have to determine what they're telling us, right, or what they're not telling us sometimes. So this answer, we'll just round this one to nearest tenth is fine. 16,894.5. It's 50399 if you're interested. Number 3 says the sum of the first 4 terms is 203, so it tells us the sum. Does not tell us the first term. Tells us common ratio. And tells us there are 4 terms. So if we multiply both sides by 0.6, that's what this value is. That crosses off. So if I do 203 times 0.6, I get 121.8 is equal to a minus 0.4 to the 4th power, so 0.0256a. Combining like terms, 1 minus 0.0256 is 0.9744a divided by 0.9744, and now I know what a is. So 121.8 divided by 0.9744, and we get an a value there of 125. This is something that comes up on the Regents all the time, so it's a good thing to look at. Number 4 has us going back to page 5 in our book. It says find out how many miles Kristen will run using the series formula. So on page 5, here, let me just grab my book. All right, so number 5 on page 24 tells us that Kristen is running 8 miles in week 1. So the first term is 8. It says each week she's increasing by 10%, so her common ratio is 1.1. And it wants us to do this for 6 weeks, so the end value is 6. So if I do S sub 6, so the sum of those 6 weeks, 8 minus 8 times 1.1 to the 6th power all over 1 minus 1.1, we should be able to plug that into our calculator and see for now the third time how many miles Kristen runs in this 6-week program, because we did this back in the logarithm unit. We also did it earlier in this chapter, obviously, and now we're doing it again. So we're showing you 3 completely different methods of getting the same exact answer. I rounded to nearest hundredth, which is perfectly fine. Hopefully this video helped. If you have questions, please reach out to me via email. Hope to see you soon.